we'll introduce Garth here. And Garth is going to take us on a journey and talk about the Internet of Things as it relates. Yeah.
Thank you, Chairman.
You want to steal my show, that's it.
That's what I was going to do.
Hi everybody, my name's Garth. This is going to be just an introductory talk. I'm not going to go into depth into any single area. I'm going to describe the concepts of what out there and then some of the boards and so forth I've seen to work with this. I am focusing more on Arduino side of things. A lot of this you can do with other boards. You can do it with the Raspberry Pi, which allows you to do it in Linux and also within Windows. I'm just focusing more on some of the Arduino type boards. So we're going to talk about what clouds and IoT have, where that is, what started over there, the basic architecture of the clouds, and then how the hubs and IoT hubs that are out there. And then we're going to talk about some of the boards and so forth out there, and then this is also going to be basically allowed for you to discuss and ask questions as well.
You sure?
Thank you.
You have to share your lunch though.
So the Internet of Things has been around for quite a while as a concept, but as over the years cell phones, internet has grown and become cheaper and cheaper and cheaper, now we're getting devices that are really cheap, and Internet of Things is becoming the next fad, and it's going to be really pervasive within the next 3 to 5 years. So some predictions out there. So by 2020, which is not that far away anymore, they're talking about having 4 billion people connected via the internet. Of that, they presume that there's going to be $4 trillion of money available just through the Internet of Things devices and products out there. People are going to be writing 25 million apps. They're all going to be getting data, interacting with data, monitoring your house. These pills that you can take nowadays that will take photos of you through you all the way through, broadcast it out on the internet. Yeah, great fun. As I say, 25 billion embedded intelligent systems are going to be there.
So there'll be 25 million apps, but only like a small fraction of that will actually be useful.
Well,
About 25.
Yeah.
25 or 30 apps.
I'm going to start working on the My Colon app right now.
There you go.
Well, it's like, think of the app stores out there. There's going to be the IoT stores, and you're going to look for something, you find 300,000 things doing the same thing. So what you choose one.
Steve's
DIY
calling
colonoscopy.
webcam.
That's right. I'll have so many followers.
All the way around.
So one of so one of the things that's going to happen as well is you think about all these devices, all these people connected and everything. The amount of data that's going to be available in the future is going to be tremendous. So they're talking about 50 trillion gigabytes of data being available that's going to be out there. Think about securing all of that.
Is that all?
Well, if there's that much, maybe you don't even need to bother anymore, right?
Just nobody can find it. It's so much.
That's right.
Can't find it in a sea of other information.
So what other things, Internet of Things in the future are going to be doing? So a lot of shopping and retail, multiple channels. The people that are actually going to have it, the phone's going to have things you can scan. Phone's a basic Internet of Things device nowadays with all the photo taking and scanning and everything else you can take. But they're going to be sensors in the store as well. The store is going to be watching you and determining who's moving around where. Do they offer this at a discount because everybody's at that side of the store, now they want them at this side of the store. So all this information is going to be going on.
Automated blue light specials.
Exactly.
Yeah.
Medical devices. I have a little watch that's measuring my activity, and it's broadcasting out. This is an Internet of Things device.
Yeah.
It's also got a GPS, so it can tell me if I'm lost. But all that data information, if this was medical, if it was now, sensing my blood pressure, my glucose, whatever else, all that data is going to go out there. So that's where people are worried about the most of security once again. Do I want all my billions of lines of data going out now being readily available to other people? Another section is going to be industrial growth. We've got great automation in this country already, but that's just going to keep on growing. And more devices, more and more intelligent ways of doing things, sensing things. As it gets cheaper and cheaper and cheaper, we all sense more and more and more everywhere and actually start to make actions based on more data that we have. When you talk to a general person about Internet of Things, the first thing they think about is a smart home. But then we've got a lot of people that worry about setting VCRs if they still have them. How they're going to live inside a VCR where everything is controlled by that. So these are what people think the advantages are generally from everyday people. Is conservation of energy, more comfort. Your house will know what you want and how you like it. But then you have the opposite about it is privacy. People hacking into your house and locking you out while you're not in the house. As I say, fear of hackers, and then the people that still can't set their VCR, still can't set their house. They won't be able to turn on their stove or do something else, and your fridge will be able to tell you when you're out of beer.
I think that's underestimated, that 14%. I think it's backwards. Wouldn't you say? That's the biggest fear is, okay, if it works, it's great, but until it works,
It'll
scary.
only be successful when it just works and it works every time for everyone.
Right.
That's
And
when
it's
it's
smart
gonna take
enough
off.
that the user interface is smart enough to know what you want.
Yeah.
I know people, that the new Cadillac, whatever, and they can't handle it, but that shouldn't be the case. You should be able to talk to the device and say,
program a Mini Cooper,
oh, really?
and those guys, they didn't have, you can do anything when you go back through 17 different menus,
Right.
and they have like 5 buttons. And you have to figure out, it is incredibly difficult, but it's great, it's
Right.
fun, but it's not for everybody.
And not to interrupt you too much, Garth.
No, it's good. It's good.
Anyway, but really, if you think about how we've come along with, let's say, PCs, although still can be really horrible things, but if you think about now, you can take a device, a USB device, plug it in, half the time, device is recognized, goes out to the internet, loads a driver, and it tends to work, usually. Ish. If it doesn't, you're in big trouble. Okay.
Well,
Unless you pull out a USB device from 10 years ago.
yeah.
It goes out to the internet, there's nothing there.
Well, as a prime example of the counter, my wife, we got her a smartphone because it hooked up to the car. We went back to the flip phone for her.
Yeah, so not quite there, but it should be to the point where you just wouldn't even want to look at the flip phone. So something's not
Yeah.
quite there, but we're
I
getting,
still like my dial phone.
there you go.
Yeah. Yeah, so,
Have you seen any information on, if this just seems like an incredible amount of information. I mean, are we gonna have to have, 10 orders of magnitude of improvement in internet speeds to be able to handle it all? I mean, is it just
5G is coming.
It's
gonna get clogged down with-
constantly, internet is growing, the cloud is pushing that, companies are moving into the cloud. So it's pushing, Microsoft's making huge, big data centers and localizing data centers all over the place and pushing that it's growing and keeps on growing. Yes, there's going to be, in my neighborhood, they're now putting in a gigabit internet. So
Yeah.
fiber.
Fiber, yeah.
Yeah, you'll see more and more high-speed broadband services, even in rural areas.
That'd be nice.
Companies like Google are looking to go to the air, and they're building a network of just always up in the air drones
Blimps, yeah.
and blimps and things that serve Wi-Fi to like broadband speed in big huge areas. Microsoft is dropping data centers in the ocean now, literally down on the ocean floor, which is very close for cooling and possibly free electric power generation through wave.
Mm-hmm.
So it's going to be pretty interesting the next 30, 40 years.
Yeah, and this is only, these predictions are for 3-4 years.
Yeah.
So That and self-driving cars, which would be Internet of Things, which is even more scary than your house, depending whose car.
Yeah, you'll have the ability to drive your neighbor's car while he's on the road.
Yeah, there.
Yeah, comment on, just sort of related to the, sorry, now shut up, you'll put me out of the room. But, I was thinking about the concern about drones. And the other day I saw a FedEx truck hauling through my neighborhood, he was doing about 45. And I thought, if he hits a kid or adult or anything, he will kill them. I'm just trying to think, if the drone malfunctions, it's probably not gonna kill me, but that delivery truck sure will kill me. I mean, there's no question about it. So the argument there for drones is probably what the heck, how many people are you gonna kill with drones? Not many. You might have a few.
One very unlucky person when it drops from 500 feet.
You don't know who your aim is.
So basically, IoT works on top of efficiently the best is on top of clouds. And rather than having your IoT device trying to reach back to your server, which you have to register and so forth, there's services out there that make this a lot easier to handle, and then you interface with those services. Here are just some of them out there. So one of them I'm going to be showing is Particle.io. They've got a chip that talks to their cloud. You program the device through their cloud, and you get data back through their cloud. There's Adafruit, which you guys probably know about the store. They have their own beta cloud out right now, free, you can go play with. Your device talks to the cloud, it sits out in a queue for 24 hours. If you don't pick up your data's gone. But it's a good, easy way for you to communicate easily.
Question here, what is the, like com is for company, .io, what's that stand for?
It's just,
I mean, is it specifically for clouds and hubs?
No,
it's a new
they have all,
extension.
yeah, they have all these different domains nowadays
Yeah,
that
they're
they're just coming out with, and
domains.
people are picking them up for different reasons. Like IO is popular with these kind of services,
Okay,
but it's not really
not unique to
not
them.
unique to them.
Okay,
No.
got it.
ThinkSpeak, Meshify, there are others out there. Azure, AWS or Amazon Web Spaces, Google, they're all making big pushes for that. And I'll just go into some of the architectures. So this is Azure's IoT Suite, and this is how they see using the Internet of Things. So basically off to the side over here is your device. Your device either talks directly to an event hub or goes through a gateway. So there are machines and devices out now in factories and so forth that are not internet aware or just talk on their local network. You put a hub, it talks to the hub then passes on all the way up. The event hub then allows you to take that information and push it through different channels. And you can push it through stream analytics, which is watching the stream of data coming through, or you can process it through into storage and hubs and different information into different sections into Azure, and process that data there, and then present that data or send commands back to the device. So that's the Azure's way they handle it. AWS has a similar idea. Once again, you come through from the device all the way through a gateway, then you actually go into a queue which is similar to the hub, and you process it through to their services or shadow it directly into your system, and you process your data, visualize it, and send commands or send information back. Any questions? Google, similar idea. You go through your devices, through a gateway, into a hub or ingestion, and then you process that through either into storage or into your analytics, which then allows you to present and have applications which do something and then maybe send information back to the devices.
Okay, so from a point of view of a user, he hooks his device up, it can talk. You're going to talk about Particle, what was it?
Particle, yes.
Yeah, okay, so let's just use Particle.
Yeah, so the next one here, let me move one more. So you are talking about here.
Oh, yeah, okay. All right, so the robot
says it on the robot.
talks to the IoT service, this is good, okay? Now it goes to the server where the guy is processing is storing or processing the information?
Yes.
Can do either or.
Either or, so that's the one whether or not it's going into storage or if it's going into, what was the bottom?
Analytics.
Analytics, right, and then it comes back to, what's the device on?
Well, this is saying that your development environment. So if you were working with this and using Arduino, this would be your Arduino IDE.
Okay,
Now, depending which device you use, you either program it back through the cloud, or you have to plug it into the board, into the robot to program it and tell it, hey, I want to now monitor this.
okay.
Are
All
there
right, so
any-
something like this sounds cool for something that, maybe CNC, where I'm gonna, like, send something up, a file up, and it sends me back G-code, for example, okay?
Mhm.
All right, but if I'm my robot and I'm gonna say, I see a wall, and then, 10 seconds later it says, I see a wall, you saw a wall.
You need to turn.
You might, it might be too a little slow, and so I'm trying to figure out.
So what happens, opposite of that, is your robot comes into a room, boom, all right?
Yeah,
Gets a GPS reading or what it is,
okay,
and does a room scan, all right? And then sends that information back up.
okay,
And in the cloud, you've got all your mappings of your previous runs
okay.
and says, oh, by the way, we think you're here. Here's the map that we know.
You're in
of
the
that
back,
area.
you're in the bedroom.
All right, so you don't have to store locally your maps?
Yep.
Oh, gotcha.
That,
I'm pretty, yeah.
or what about,
And you don't have the processing power on the robot to do SLAM.
mhm.
Right, well,
Do it in the cloud.
Another
I'm trying to figure
example,
out, now, okay, Ross is kind of, does sort of the same sort of stuff, but instead of being on the cloud, it's
On
on
the
some,
robot.
either
Or
on
your
your robot
laptop.
or some
Right.
local computing
Mhm.
power, and depending if you're using wireless. So, in a sense, I guess it is an IoT,
Yeah.
think about it.
Kind of, yes. It's
Okay.
leading
another
to it, yeah.
example would be is your vision system says, oh, I wonder what that is, and it sends it up to the cloud and comes back, that's a coffee cup.
Okay, so that's,
Object
there, so it could
recognition.
have its learning algorithms up actually on the cloud.
Mhm.
All right, so
And what
so-
about if you have 3 or 4 robots swarming?
They can communicate to the cloud.
Yeah, they can communicate to the cloud. I'm not sure that would be necessary.
So I guess the question is, what's the latency of the cloud? What are you
Yeah.
talking?
Yeah,
That's the question.
About 200 milliseconds round trip.
Depending,
Depends on how good your internet
depending on your connection, what your pipeline is from where you're working. If you're working through your phone, it's probably slower. If you're working off a Wi-Fi spot, it's probably faster. It depends on where it is.
See, that's where I could see the benefit of, okay, if you've got a robot, I assume in this scenario, it's connected to the internet via Wi-Fi. It's got a
Yep.
Wi-Fi adapter.
Well, actually, that's what I'll talk about the boards. The boards
Okay.
actually have that on it.
Okay. But I guess the question I'd have is, it would be nice, since you've now got that Wi-Fi transceiver built onto the robot, it'd be nice to be able to create a direct connection from a PC. I mean, yeah, have the cloud stuff available, but rather than, physically use your Wi-Fi network and talk through that locally with what's the round trip, or what's the typical latency in your home network? It must be only a few milliseconds typically. About a millisecond?
About
Okay.
less than a
10
millisecond.
milliseconds.
Oh, really?
on average, yeah.
See, to
Well,
me, that would be
back and forth.
great,
Yeah.
because one, you could have near
Let's
real,
process
or
that.
virtual real time between a laptop and your robot, but also then have your cloud for your lower latency, other
yeah,
things.
but I would say Ross is an implementation of exactly what you just said.
Okay.
All right, that's how I would interpret Ross.
The other thing, like Dave said a minute ago, one of the reasons you might think about using the cloud is for object recognition or machine learning. There's a lot of big pushes in machine learning and analytics and things that use a tremendous amount of compute that one laptop would never be able to do. And you'd be able to spend hours training through a machine learning algorithm, but only milliseconds garnering the output of that through this. So your robot could go in to an environment that it's never been in before And with a vision system, it may take a couple hundred milliseconds, or even a second to get your answer back, but you can go in there, scan around, let it tell you where everything of value is, and then you can build, your local execution.
And I do see that would speak where if there is somebody out there who's just creating this humongous learning library, I mean, we used to do this at TI for defects, but I'm just saying that, somebody's up there like, okay, is this a chair?
This is every possible type of chair.
This is another chair.
Yeah.
And then, you send off something and it says, well, I think it's a chair. When it comes back, that could be, I could see where that'd be really useful because,
They would love to know where all the chairs are so they could put them.
yeah.
So the other thing is,
DPA.
the other thing that you think about is, if you and several robots share the same hub and a service out there that actually does mapping, and you run your robot through a park, and it maps out and says tree, whatever, maps it out, and goes and does that. The next person comes along and his robot starts to go, picks up your data that's already there, corrects, sends other information. Machine learning says, hey, there's a tree 20 feet there, but there's one 22 feet over there, and the third robot says 23 feet over that way. Maybe the tree's in the middle of that.
Yeah, I can see that in a factory case too, where you have a factory environment where you might have different machines, different stations, things like that. You might have a lot of care put into defining what that environment is in certain stations and so forth, so that a shared collection of robots then could use that information.
Yeah, and they've been doing that in private clouds and private devices and so forth over the last, say, 15 years or so forth with the automation and been doing it. But it's all been contained within that network, within that building, within that item. And the equipment to do it, to get a board, a computer, you're normally running a PC, so that's going to push you up, $300-400. Then you've got to get a wireless card. You've got to get all, a whole bunch of stuff to get it where now you can pick up a chip like this, the Photon. That's got everything on there, gig of memory, I/O, and the board to communicate to Wi-Fi, $19.
Now, what is the service?
Yeah.
I'm just curious, what is the service cost to use? You said this one goes specifically to their service.
Yes, so this one, when you buy the device, you're allowed to unlimitedly use their service for that device.
Is that through Adafruit though?
No, this is Particle IO.
Particle IO. Adafruit's free as well.
Adafruit's free, but they don't even care which device you use, as long as you register, and they'll give you a ID and you program your device to say, I am this, send it. Now, both these services are basically doing a queue out there for a massive queue for everybody, and your device would drop this data in there, and it would sit in there, and if you don't pick it up within 48 hours, it disappears, it doesn't care. So that's how they...
Are there any open source alternatives to these cloud services? So you could do a private cloud if you didn't want your information going out there. I mean, not for the algorithms for detecting objects or something like that, but just for the data storage, a private cloud alternative. You could basically store your data yourself, but the data in the hub that you're sending to is encrypted and assigned to your own ID, so nobody else can see it.
Right.
When you pull that data out, you could stick it in any service you wanted, making your own private cloud. You could pull it down to your own machine. I don't know of any. Well, there are paid services out there. You could
Nothing open source though, it's just like a full
I think there is, but I haven't
IO.
played around. There are some open source stuff that I haven't played around with, but like the Cesar is very, very simple chip. This is the 8266 chip basically, which allows the communication to a Wi-Fi. But it is very simple, and it does web requests. So basically you're just calling out to the web wherever, as long as if you have your own personal PCs or server that's connected to the internet, that's got a public domain IP it can reach to, you could send a RESTful call to that and store it yourself. You can pass that around if you want.
Yeah, how much is this?
Actually, that's what we're jumping ahead of me.
It's sub $20, I think.
Well, I'm just
Actually,
saying, I just
Where's
bought
your
a
car keys on
clone
this one?
on Banggood for $3.50. That's why I was looking at it, and I was saying, hey, this looks familiar.
Is that the 8266?
Yeah.
But that's the Adafruit version of it. You can even get other ones. I've got a list for each one of these. But let's talk about just, everybody loves this picture for Internet of Things. This is like the Uber architecture picture where everything is connected to everything and everybody's doing everything, all going through the cloud. All right. The other major picture people like to show is this type of picture where you have machines, devices, windmills. You end up with storage farms, processors, whatever you want, refineries, all these talking to the cloud, to the data center. The data center then collects all that IoT information. It then sends up for visualization, and that would then do analytics, machine learning, so forth. Think about this 50 million gigs of data out there that you're actually working with. It's going to be hard to understand. So all this is processing it down, making it easier that people can see, and then making decisions from it.
I was just looking at that picture and it's a little scary because a lot of the stuff is happening around things that don't involve people. And look over there, end user, not a lot going on. So do you really need people at all?
No.
No, that's it. That's what we're working on, right?
That's what we're working
Obsoleting ourselves in 30 years.
We're working, nicely done, nicely done.
It's like there's no people.
We're trying to accelerate the singularity.
That means all we have to worry about is drinking beer and fishing.
Oh, okay.
That's a very good point, but you think about it now as the top companies in the stock market right now. Back 20, 30 years ago would be like the Bell, Marvell, and thousands of people, and they were a huge, big company with billions of dollars, whatever. Now you've got Amazon or Facebook, who's got billions of dollars and 100 workers. So, yeah.
And we're gone away, aren't we?
We're being obsoleted.
We are. I mean, we got the little sensors, little eyeballs and little ears and
Yep.
all that. We're just,
Go back to the
we're going away.
Yep.
Well, I guess the
data
positive side of
center
that, if
storage.
it costs too much initially, that uneducatable part of the population will still be able to get jobs because it's just going to cost too much.
Dishwashers.
Yeah.
Hamburger
Assembly
service.
line workers.
Before you have the data center and the storage there,
Mm-hmm.
who owns the data on those machines, hopefully?
The person that's paying the subscription for storage in the data center.
So $19?
No. So $19 gets you the chip and the ability to talk to this system, all right? This system is just a gateway and a queue. Your data drops into that queue for this chip, and you can then pull that data out by requesting for your data. If you don't ask for your data, in 48 hours, your data disappears. It's deleted. This is not, now if you were using Azure, Amazon, so forth, you would then have to pull your data from wherever it is or use their hub, get their data, and then stick it in storage, either be on your on-prem storage or storage in the cloud. But you'd be in your subscription. It'll be storage that you're paying for, so the data belongs to you.
What happens one day when I stop paying for it?
Data goes away. That's the nice thing about cloud. It's all
Bucket.
bits and zeros. They pull the plug in, it all vanishes.
So they go in and they remove it?
They would just basically repurpose that information, that hardware.
Repurpose that
The junkyard of the
information?
future.
Not the information, not the information, sorry, please correct.
You're
A little
paying-
Freudian slip there.
You're
Yeah, Freudian
paying-
slip, all right.
You're basically paying for storage space on a hard drive on somebody else's computer. You're renting space on the hard drive. When you quit paying your rent, they delete your data and that space is then sold
Well,
to somebody
Facebook
else.
doesn't delete your data when you stop paying.
Yeah, pay for
I
Facebook.
mean,
Do you pay for it?
You
I
pay
guess I'm
Facebook?
asking about a trust issue.
Well,
I understand that
Well-
you're renting space on their hard drive.
Right.
With my personal sensitive,
Right.
valuable
Well,
information.
but-
I'm
but
asking
in-
what
but in the
happens.
case, in the
How
case
do
of
I control
Facebook,
that?
you have to always remember, if you're not.
Facebook was a
If
bad
you're not
example.
paying for it, you're not the customer,
Exactly.
you're the product.
Exactly. And so does that apply here?
No, because you're paying
Well,
for
it
it.
depends on your service.
This is a different case. You're paying for the storage of your data.
And you're trusting that one day when you don't want it anymore, they will remove it and not repurpose it.
Correct.
Well, it's all
I think it goes
encrypted.
beyond that,
You're-
right?
It's
Well-
encrypted and you have the key.
So
Is that
most,
right? Is encryption built into that
Yeah.
little chip?
Yeah.
not
it's high.
no, it depends on the service that you call it.
I see.
This one is not encrypted, but if you were using Amazon or Azure and so forth, part of your subscription as part of you get token keys, and everything is actually encrypted. You have the private key, and then you use a public key to access and get that data.
Do I make that private key?
Yes, you can actually either make the key, or you can pay other companies to give you the key that
Why
are
would
not,
they make a key?
that are not.
By the way,
Why would I do that?
if you lose the key, all you have to do is you just need to know someone who's got a GPU farm, and you need to burn about $5 worth of GPU time to get you your key. That's about how bad it is now.
Yeah.
Depending on
But it's on the cloud, because you don't have to buy $10,000 worth of GPUs. You just pay $5 and you get the GPU time, and anyway.
Yeah.
I have a question for you. When I think about this right here, I don't think about it storing something. I think if I'm Microsoft and I want to sell you a software program, I don't want you to have a copy of it on your computer. I want you to run it through the cloud, so you always have to pay me a subscription fee every time you want to use that software.
And that is a sort of subscription model that's used by a number of places. Think about your garbage pickup people. I've been doing that for how many years?
Yeah, but I mean, where I work at, we had to rent a bunch of software. The software wasn't resident on any of our computers. You'd have to go to the internet to use it and get
Yeah.
a license, a key
Yeah.
to use it and everything. I don't see this as so much. I mean, we did rent space too, but
Mm-hmm.
like
Yeah.
you said, if you don't pay the rent.
Yeah.
God. Yeah.
There's lots of different types of services now with cloud services, right? So you have infrastructure as a service and software
Platform
as a
as a
service,
service.
platform as a service. So it depends on how you want to use those resources. You can write an entire application, create your whole platform up there,
Yeah.
and your customer base simply goes out to some web portal, and they can run all your software. It's all web-based, it's all the storage is in the cloud, it's all super scalable, nothing to install. Updates happen automatically out there, it just works, with the new features.
Updates and you can't figure out how you use it, so it's different than the last time you used it.
Yeah, sometimes.
Or
It's
it
all
breaks your
automatic, though.
system.
There's no system to break, that's.
No, I'm saying your update bricks your local
So
system.
that's a different type of.
Yeah, so there's advantages and disadvantages. You can buy all the storage, all the servers and everything in your own environment that you want to do, stand it up, manage it, update it, pay the electricity fee to run it, maintenance, bug fixing, securing. It's up to you whether you want to pay that way or pay the other way. The unfortunate part is once you buy that hardware, you buy it for the biggest time. So if you do all your sales during Christmas, you buy the hardware to run in Christmas and then you have it idle for the rest of the year.
Use
Whereas if you
5%.
if you use it in the cloud, you can scale it up during December and then scale it down for the rest of the year.
And
If you're lucky,
charges
you
are
can scale
based
it
on
up.
usage.
Yeah, depending on what service you're using and so forth. But there's many options.
This is a stupid question, but how does this differ from what Ron Perot was doing in the 60s?
You mean UCC?
Yeah, I guess that would make sense.
No, it was
EDS.
EDS.
Oh, EDS? Okay. Well, UCC preceded that.
Most of that was all private cloud type stuff, is my understanding of EDS. You talk about,
I
there
don't
was,
know much about it, but I'm just saying that it sounds to me like what you're,
Time
I don't
sharing
know.
system.
So was that time, so timeshare, in other words, you're talking about a centralized computing facility where all the data was stored, and then you had your dump terminal, whatever, and that sort of thing.
so probably the easiest way to say it would be what he was doing was very expensive to buy into, whereas with the clouds and the internet and everything, the prices of these coming down to such cheap, now we can do it.
Right, and it's wireless, which is nice. In the 60s, you were wired into a system.
Yeah.
Yeah,
So,
the
full-
antenna
I had to have
and the
full
antenna
line.
dish is
Yeah.
fine. I like those.
2400 baud modem, right?
I see this as
No, 300 baud.
is
300
more as, think of it as a sensor interface. Oh, that's what this really is.
right.
I mean, you're
300 baud
storing
acoustical
the data, and maybe you have an application in the web that, but what you're really doing here is use, before what they had before, it was a company who was storing their personal, like, maybe their finance information out on the web. Here, this is you tracking the humidity in your bedroom. You know, this is you finding out.
Citing stuff.
Well, but
different
everything in the
cameras.
house though, when you had the colon pill that you ran through your body with the
Yeah.
camera, it keeps the toilet from flushing. I know
Right.
that's kind of a little. Because the toilet is internet enabled, and of course you
Well,
gotta have
that's- I
that.
think that's the kind of the thing.
And you know, don't let
have
your
to-
daughter flush a G.I. Joe or the
Right,
Barbie
right.
down.
Yeah,
Oh,
well,
sorry,
on,
okay.
you're hitting on the other side of it. The other side of it is,
The Barbie's
like, do we
gotta say.
really need
Splash cam?
I mean, do we really need a Wi-Fi enabled toaster?
Maybe.
But I mean,
I
here's
can't, you know.
Well,
in my
because
mind,
then
I
your
just
kid
can't
that's
see that.
connected, you know that your 5-year-old shouldn't be within that close proximity of the toaster, and you notice that they put the Barbie in the toaster, because the Barbie's got a sensor, and so that the system analyzes Barbie and toaster, child activating, you know. This
Not
is-
only that,
Bobby in toaster.
but it uploads it all to the cloud.
And you get statistics
All
on it.
this personal
Yeah.
information
Yeah.
to the cloud,
So for 48
where
hours,
it will
you
never
figure
be
out if
hacked
it
into,
happened.
because that never happens.
but like,
So
And it will be
your
kept-
son or nephew's branded as an idiot because he's sticking Barbies.
When he goes to get elected.
That's right.
And
right.
his college prospects just went out the window.
That's right. It's gonna be one of those manual levers, you know.
This one and then this
So
one.
he'll have a job.
Right off this one.
I mean, that card he has right there, that thing doesn't necessarily go to, it just has a Wi-Fi interface on it. It can talk to anything if you want it to.
Yeah, that's the,
I mean, I
that's
like
the,
this,
the,
it's a really good example.
Well,
of
what do you
how
know
that
that means?
makes sense.
I mean,
Yeah.
Talk is just
I
the
always
Internet
look
of
at-
Things and how you're connecting devices to a network, whether it's your
And every-
network or the internet network or a cloud or anything else.
so as you can see, you can buy the Photon for $19. The interesting thing is you can buy it without headers or with headers. They're both $19. So
They saw the headers on for you or they don't?
they do.
Yeah.
It's like, okay.
That is cheap. They would give me.
No, at the time of the extra step there. So the Photon is actually a pretty decent little chip for $19. It's Arduino compatible. It's got a reasonable amount of RAM and flash as well that you can store. It's got 18 GPI ports, as you can see. It's a fairly decent chip that can be used. So you can do it for more than just, you could run a small, you probably could run that robot.
Yeah,
Over
yeah.
that.
like,
Yeah, 120
In fact, that's
arm,
what we're
33.
planning to do later in the year.
Yep.
That's good enough to do.
how fast is the I/O on that? It has some I/O
It's an
on
ARM
it.
chip, so it's a
120
120
megahertz.
megahertz clock.
Yeah, that'll,
I don't know if that's single.
Yeah, probably has 1 megahertz I/O on it.
Yeah.
That takes.
but not a lot of I/O, but you could interface to another ARM chip for another couple bucks.
Yep.
So I guess it's got a.
So you could do SPI, you can do ITC, you can, you know, you
Yeah,
could,
you got
you could-
I/O on it.
yeah,
That's cool.
bunch of stuff.
Let's put one of those on our robot, yay.
Because the Adreno's only got like 1 megahertz, it's pretty slow, or 100 kilohertz or something. It's
Well, if you get the new Arduino 101, it's a 32 bits running at 40 megahertz.
Yeah, it's an Intel.
Yeah.
Yeah, the
Chip.
Curie chip, yeah.
And I think I'm down another one.
So, the thing to remember about this guy is you can't program it using the Arduino IDE. It's actually got a web page on their site that mimics kind of the Arduino IDE. You put your code into there, your links and everything to that, and then you hit compile, and it will send the code to the chip and change the chip, the program on the chip. So if you were using this in a commercial setting, where you had a Tonka toy truck and it had this chip in it to make different new sounds or whatever, you could push updates out to all your people out there code-wise without actually having to go and physically plug each one in.
Can you program it without going to their cloud? I mean, can you get,
You would, but then you're basically replacing the bootloader and so forth on there are people that have done that, but you kind of
also the
going
boot-
around the whole
Yeah,
point
it
of
wasn't designed.
dying.
So the
I think
bootloader
there's
automatically
another
goes
option.
to
There's
some
another
app,
option
some
that's better.
predefined address that's burned.
Yep.
from it.
So another thing that's tricky I found when working with these things is programming the Wi-Fi for it to identify to connect to. Because it's pretty tricky, you gotta get the SSID, you gotta have the password and so forth, and you gotta be able to do it. So for what I'm doing for demos and so forth, is I have one of these. This is a Western Digital portable hard drive. It's got a nice feature that I can stand up a wireless network and connect it to another network, another WAP, and pass it across, bridge.
So you're saying that's a Wi-Fi bridge?
So it's a Wi-Fi that's bridged to another one. So all my little devices for demos talk to this guy, and I come in through a web page and I tell this guy to talk to here. So I don't have to redress my chips every time.
One question I had on Particle IO specifically,
Mhm.
since you have to use their cloud to program it, you're putting in sensitive information like your Wi-Fi password. Is the communication channel back a secure link? Did they have a cert burned into that little chip too, or is it?
It's HTTPS, but I don't know, when you're actually using the web page, that's, I know that is,
That way, but
That way.
coming back, is it secure coming back when?
I don't know, I
That's what
haven't,
gets
I haven't tried to
burned.
actually intercept to work out, I haven't looked at the details to find out what that is.
Yeah.
His bank account's being drained right now.
As we speak.
But as you can see, so there's basically, everything's done through, so dashboard, as the device comes up, you can see the status of the device, whether it's active and so forth. You have a log and so forth, so you can tell when something's happening and when it's responding data back up into the queue or through the internet. And that's basically the IDE.
Pretty colors.
So how do, when you use this right here, and you want to create like a library function, set of library functions for it, and the IDE's up there, then all you get is just your executable code on your computer, and all your library functions and everything are stored on this server.
So you don't even get your executable code. You can take and upload a library that you've written, or you can upload your sketch into this, and it'll hold it and store it up there that you have access to. When you hit compile and so forth, it's sending the compilation keys to the actual board as it's doing the upload
So all you got is just your compiled code
on this.
Your executable.
Yeah, the executable.
your.
So online, you've got whatever little structure of folders and things. You
Yeah.
can create projects, I assume. and
So these are, my apps are the apps that I have.
Okay.
And then after that, if you click down here, if I had been sharing, I would share from here, but I forgot to bring my adapter for here. You have the ability to go to libraries and public apps. Other people make their apps public. And then you can pull an app and say, I want to take and branch this app and so forth. So it's pretty simple, it's interesting. Now, if you're going to go use this to do a product that you're going to sell, they will discount the chip price to you by thousands or whatever it is, but they also then start to charge you a $2 fee to join their network, where it's a one-time fee. So,
Is there any revision control built into this, where you can store versions?
Git integration or something?
not that I know of. So what I've been doing is using Visual Studio, playing around on standard Arduino to get close to what I want and storing it in Git or whatever I want, and then just copy, paste, drop it in and go.
You don't want to do big furry projects, in
Yeah.
other words.
Yeah, but there is also, this system automatically does drop updates to your chip when you log in too. So I've had that happen to me, and I thought, why is it taking so long? My program's a little, I'm trying to blank it out, but it's got this big program coming through. We basically did a new BIOS to the chip,
You want a light
That can be
blink?
You mean like a second Tuesday?
Well, actually,
Tuesday, coming after.
Just, that way you can, it's like your laptop. I
Yeah.
just got a Windows 10 laptop, it's about to get me fired because I'm in a rush and I don't know how to disable the automatic updates. Somebody told me there's a way to do that. But there it is. I'm updating. Don't turn me off. I need to be someplace. I'm gonna be
I need to
fired.
go home.
Yeah, no, I need to be to a meeting.
I've been
Really
okay
easy
with
to
when it's
disable
come up and given me the warning, but I've been in a meeting and come back and go, I wasn't around there when you gave me that option. You just now decided to go without me.
Been timed out.
Yeah. So actually, if I show you this.
So if you build this into a life-saving device, just remember it might take
So
20
as you can
minutes for
see-
some days,
When, it
Hey, I
first-
got it.
when this guy first comes on,
Yeah.
the white light flashes white, that's it's getting power. Then it runs the green, where it's actually running its a bootloader, and then once it turns blue, it found the network and it logged on. So it's now joined to that to the WAP. So if you're sitting on this and you start to do something and you get a red flashing light for a long time, that means it's been uploading code to it. So you're suddenly going, what's going on?
Go get coffee.
Find the edge of the table.
You just really build confidence in that.
Oh, you also can get one of these, which I haven't played with yet. This is, whoops, that is a Photon Phobot expansion. So it's a motor driver expansion as well as a port here for the HR204, whatever, ultrasonic.
Okay, yeah.
Actually, there it is, that's there.
Yeah, so it has a sonar interface, has an I2C interface, and I believe the chip has one serial port, doesn't it?
Yes.
And it has a serial port on the Photon. And it looks like a motor driver, 1, 2, 3, 4, so dual motor driver chip. Oh, that's cute.
Yeah, pass it around.
Who makes that?
I believe you can get it at Adafruit, but have a look at it. I believe it's actually the person might be on the back.
Good.
I think it's somebody like Phil or somebody. Monk makes, yeah.
Oh, yeah, I know.
Oh, yeah.
No, come on.
No, I have.
Oh, you know.
There's some-
It's
just
an
2
open
days ago, I was
source,
looking at
it's an
that.
open source board, so. All right, let's go on to
Some
the,
monk in Tibet, right? He makes stuff.
No, I just bought this right off my sensors for my Hall effect sensors.
so here is the next option that's out there that a lot of people use, which is the 8266 board. And there's many options out there, and it's quite a lot cheaper. The Hussar, which I was showing you around, is $9. That's the one I got. I've got a Feather as well. That's a Feather, which is a expansion, and that's what the Feather is. It has built-in battery support, and you can have Feather boards, which are little shields that you can put on top of.
Is that an LCD?
That's an LCD, yeah.
Probably an
And
OLED.
they've got dozens now of little shields. Or
Yeah. Yeah.
Every week they release another one or
Wow.
two of those things.
Yeah, Adafruit.
This is a cool chip.
And that's $16 for the Feather. So,
And like I said, I went to bank, actually it was AliExpress, 3 to 4 bucks.
you can get you can get the chip itself.
No, I mean,
Yeah.
that exact board.
Yep.
Yeah, so.
The downside on this board, it doesn't have great I/O support and so forth.
But it's getting better.
Is it battery support? Does that mean the integrated charge controller? or-
On that one, yes, it's got an automatic LiPo charger on it as well, yeah.
So plug in a USB or whatever the charge is, or
Yep.
an external.
No, you plug it into USB and it will charge the LiPo.
Okay.
They've also recently came out with another Wi-Fi chipset.
That's the next one.
Okay. Yeah, they're gonna make it a feather board as well.
Yeah,
in
it's
November,
ready,
so-
it's there.
What's
yeah.
a feather board? What's a feather board?
A feather is, light as a feather, is where the term comes from.
Uh-huh.
It's a
Shield.
it's a standard form factor that Adafruit came up with.
Uh-huh.
It's that size and it's designed to be expandable through stacks.
But so it's not it's not the same footprint as a Arduino, right?
No.
It's an Adafruit.
Yes.
It's an Adafruit.
But it's about the same size as a Nano or a Mini Pro,
Oh, okay.
but the pins out are not the same.
So can these
They already
support,
stand by something, I understand.
Just a question, I don't know much about all these protocols, but
Yeah.
I just remember years ago, like UDP or one of those was, pretty good for like not sucking a lot of power. Like, what do you have as far as, since you're talking battery operated devices, if I'm gonna have it connected to my home network, what do I have there as far as to help me? I mean, I assume I can have it wake up periodically and talk to the internet sort of thing, or talk to the Wi-Fi.
Yep, so these two are not the most low power. These ones pretty much draw a constant power. The next one I talked to is just released, is a low power version which goes to sleep and all that type of functionality.
Okay.
These two are, so the particle I/O is pretty comprehensive with the amount of outs and the hardware and the software with it. This one's a little bit more bare boned and doesn't have as much support. The libraries are constantly being involved. They are getting better over the last month or two. But I was trying to do I2C, I2C on it. And the library with that, the wire library was very, very rough. So it's still got a long way to go with these boards.
That means your device didn't work when you tried to talk to whatever you're trying to talk to.
It did, but I had to fiddle with it. I had to fiddle quite a bit. So this is the Hazar, which is basically they've done some pinouts. By the way, both this one and the particle, they're all 3.3 volts devices, so you're going to have to level shift if you're interacting with any 5 volt stuff.
For the record, this is not the chip I was talking about.
You were, no.
There's
That's
one that's
coming.
the replacement
Okay.
for the
There's one that sees
C3000.
So this is the basic, the chip itself that actually drives all of these. And you can pick up the chip for like $1.99 if you can actually.
Yeah, but you wouldn't. I
Yeah.
mean, the modules,
Yeah.
the modules cost as much as the chip.
Yeah. All right, and the good thing about this is that you program the chip directly via plugging it into your USB port. You don't program it across the internet, which could be a downside if you want to update it once it's left your control.
Yeah, the Hazar is interesting too, because you can program it using Lua scripting.
Yes.
Or you can burn your own Arduino script sketches.
I want to say, I know, I read just recently, they've got C now working on it.
Let's see.
Originally it was Luna.
Yeah.
And then I think, I want to say that they're even looking at Python coming onto that.
I've heard about that too, yeah. I saw something about it, but
Yeah.
haven't played with it yet. All right, this is the one you're talking about, I think. Yep.
That's the one.
So this has just been released, and they're already out of stock.
That's like the $5.
So number one, the
Buy.
price on this is significantly higher. This has the Win C1500 is a very, very, very good Wi-Fi module. It's built into this on top of the processor. So this is a processor and a separate Wi-Fi chip, whereas the 828, that one there is sharing the chip for both. This is also low power, it has sleep modes, it's got the ability to do encryption and so forth on it. So it's got a lot more features on this than either of the other two.
This one though can also be just set up as, if you didn't want to screw with it, you can just set it up as a Wi-Fi module basically.
Yeah, both of these you could turn it, you can make them web servers.
Yeah.
The AT-SAM D21, is that an ARM processor?
Yeah.
I believe so,
It's
yes.
SAM. It's a
Yeah.
Atmel. So what is Atmel now? Oh, microchip.
Microchip.
So here is some information about this one here. It's got
I don't
more,
think it's actually finalized, but it's gonna do.
so this one's got a lot more GPIO chips. It's got a lot more PWM chip support than the other ones. It's got a nice set of analog inputs as well. This one here, if you were going to go into robotics, would be probably better for you, just the sheer amount of
Not enough
ability.
There's not enough memory.
What do you mean, where do you see the?
Yeah,
32K?
flash, or
That's RAM.
256.
256K of flash, 32K of
The other one,
Yep.
the other one gave us a gig of SRAM.
yep.
This one doesn't have one.
But, yeah, but you got your.
I
But,
can
but
run what I
you do
want.
that you put that all up in the cloud.
That's
right.
As analog inputs, how many bits are the digitizers, that thing, any idea?
Oh, 10 probably, or more.
Yeah,
10 or 12.
Yeah.
10 or 12.
Well,
That's pretty
isn't
high.
it really 10 analog inputs, or is it one analog input and a pin multiplexer?
Well, yeah, it's a pin multiplexer. I mean,
You can't run times all simultaneous.
No.
That's a couple microseconds.
180D converter with multiplexer.
Yeah. But,
Yeah.
yeah.
And once again, that's the same as the other one on how it's actually worked. Then we get to these ones, which to me, number one, I don't know, has everybody caught on the big fight going on between CC and .org?
No.
There's a big, big battle going on with Arduino right now. This is actually manufactured by the .org guys, not the .cc guys. And there's trademark wars going on. Ada even refuses to stop those because of copyright problems and so forth. But the price of that,
Isn't that what the .cc stands for, is Chinese copy?
actually, it seems to me it's almost the other way around. The CC's the
original.
the original, and .org is now Chinese copy. But yeah. But the price of these pieces are compared to, so this is a pretty good Wi-Fi shield, but for the price of the Wi-Fi shield, yeah. So I haven't gotten much deep into this. This MKR 1000 is apparently a new one that's coming out, which is similar to the Particle, a single chip device. It's been coming out shortly, hasn't got out there yet. So I haven't gone a whole lot of detail into this because basically it's, when I look at it, it's too expensive for me to play with.
It's not $4.
Yeah.
What's the range on the Wi-Fi on all these? It looks like the antenna's pretty wimpy.
100 meters is more or less what they say.
100 meters.
That's bound to be
100.
clear
You
on
mean
the
10
moon.
meters or 100?
Line of sight.
Line of sight, yeah.
With that little wimpy antenna?
We'd have to test it.
So
Yeah.
3.
With no walls.
No
outside.
walls, yeah.
I'm thinking more like 50 feet.
No metallic circuits.
Yeah, inside probably, one room, you
No
know,
metal studs.
or one through one wall maybe.
Yeah. And some of them actually do have spots we can put an internal antenna on them.
Like the ESP8266 modules,
Mhm.
there's like 12 or 15 different modules. Each one is a little different. And
Some have connectors and some have built-in
some of the
antennas.
Antennas are external.
Some of the bell connectors. So if you want more information, Meg seen this month's episode came out, and there's a comparison section that's off the magazine. There's an insert that drops you to a page in the latest website, which has got all the boards, I/O, and comparison between all the different types of boards. IoT boards and standard Arduino type boards, and even non-Arduino type boards. It's here, it's ready, people are starting to use it. I think as a group, as a club, we should start thinking about doing it as well. Maybe we should even start thinking about changing rules to allow competitions using that.
Well, some of the competitions do.
No, but I'm talking about changing competitions to allow communication between the robots. Maybe doing.
No, they do. Some of the.
One of them allows a swarm.
Yeah, 5-spot allows it.
Can does.
Okay, that means all my
Can-Can,
robots that I don't have ready for the
Can-Can,
contest can all tuck
And I
amongst
believe
themselves and
Can-Can
say,
software
oh,
too.
we're just so this is awful.
I think it was.
I think
Can you do anything? No.
I think I'm
Oh,
a
B2
B on some of
The start
them.
thing was to allow people to play with ROS.
Yep.
So that opens up the whole door.
But what about doing something like hide and seek, where there's one robot that everybody has to identify where it is?
When we get 10 of the same robots, I'm all for it.
Yeah, we can discuss new competitions
Yes.
and things like that, but we've got a set right now that we're
Yep.
working with. Once, like you said, we get the robot kit up and running and we get.
As I said, this is in the future.
Crawl
Let's
first.
Think about it, yeah.
Crawl first.
Yeah, we can definitely talk about some of those.
Find the
Um,
only female in the cloak.
So you got to questions, so.
Yep.
This back up a little bit. I wasn't familiar with that feather form factor. Since they made the decision to not support Arduino, for which there are thousands of shields out there, like with the, well, the BeagleBone has its own, capes, as they call them. The reason to do that is because you want to have an interface that's better than the Arduino, and that one looks like it has more pins.
Yes.
Is that in point of fact the case? Is that a?
Well, it depends on which model of Arduino. So if you go to the Mega, which has got 54 input-output pins, it doesn't have as many as that. But it has more functionality than, say, the Uno, I believe.
So it's between the Uno and the Mega.
Yeah. But the idea is also that these were smaller, lighter weight, low power consumption. It was more around the wearables, more of
And this would be like robots talking to each other.
well, that or devices. One of the things that I was thinking about doing with this was making a Wi-Fi logger. So I was going to add a card and a GPS logger and log all the Wi-Fi ports as I walk around and keep a track of signal strength.
War driving machine.
Basically, but then I can take it back to my robot and try to use that for triangulation.
Interesting. I'll have to report back the results.
But does that, again, I guess we'd have to look it up, but I'm thinking that probably has to be faster than the IO on the Arduino, because I have a Mega 256 now, I know it's really slow.
Yeah, the Mega 256 is still
16 megahertz.
16 megahertz.
2560, I guess it's called that.
Yeah. As I say, if you want speed right now, the 101 that's just been released, that's also on the board, which is the same size as the Uno. Has low energy Bluetooth on it, as well as a accelerometer on the board itself.
Yep.
There's the
And it's
zero and the
$32
two,
to $22.
And we're also looking at the STM F4 series as another platform that we're going to port all this stuff into and have a robot.
Use the Nucleo board.
The Nucleo boards, and those will run anywhere, around 100, and there's other versions that run 200 megahertz, 32 bits.
32 bits.
$10.
You know, the IO is how fast the whatchamacallit is, they run all their software and everything, the IO is still slow on it,
Now,
It's more because of
looks
the
like
software
it's-
Yep.
interface.
Yeah.
Would you
directly
be willing
control the
maybe
bits that are the
later in the
IO,
year
it's fast.
as we progress